Good morning, students. Today we are going to learn about Einstein coefficient inside the lasers. Okay. Last class we learned about what are the characteristics of the lasers. Now we are going to learn about the Einstein coefficient. Okay. What is in this class also? We are going to learn about what is the absorption, the spontaneous, stimulated emissions. We are going to learn. Okay. This concept is started with Einstein. That's why it's called Einstein's coefficients. Einstein's coefficients. So Einstein coefficients. So we'll start with first one is absorption. Absorption. Concept we are going to learn, and along with that we will take out the Einstein coefficients. So I'll take out two energy levels. You know that where you have the energy levels. Okay, so you have the atom. Inside the orbits are divided into different energy levels. For the electrons, we have a lot of energy levels. So there is no confusion for the electrons. But as we have a lot of energy levels, we have that is a confusion. That's why we have taken two energy levels. We have taken, and we will discuss about the absorption process. So can I consider for these? Electron E, so energy level E1, E2 for the electron. So what we are going to discuss in general words, ground state and excited state. Ground state and excited state. For electron, it's a E1 energy level, it's a E2 energy level. Okay, now. So always these electron will going to try to sit at ground state only. Okay, try to sit here ground state. Suppose we are giving some photon energy, some energy. Okay, this is called pumping process. We are giving some energy. So the energy E equals to h nu. Can I consider E equals to h nu? Now it receives the energy and we are going to jump from ground state to excited state. Ground state to excited states. Now this process is called absorption. Simple words. Now we have taken two energy levels. Okay, electron always present at ground state. Now we are giving some energy. Using that energy, it will receive and it will absorb, and it will take out. It will going to jump from ground state to excited state. Now this process is called absorption process. Now can we take out here spontaneous concept? Spontaneous. So when I take out spontaneous concept, once again I will take out two energy levels. Same two energy levels I will take out. Okay. So you know that this is a E1, E2 ground state, excited state. Our words. Now electron is present at the situation. So E2 energy level. Electron present at E2 energy level. Now, so it will not stay here more time. It will stay here very less time. How much less time it will going to stay, sir? So we will say that 10 to the power of minus 8 seconds. Okay, 1 second we are going to divide with. So how many zeros? 8 zeros we are going to divide. That much very less time we are going to stay. After that, it will come back to once again ground state. It will come back to ground state. Okay. There is no force. Automatically will come to ground state. When it will come to ground state, it is emitting some photon. Why? Because so it already taken here the photon. That similar photon, same energy will going to reach us here. E equals to h nu. Okay, so when electron will come to E2 to E1 state, means excited to ground state, it is emitting one photon without any application of external forces. Automatically will come. So in this process, how many photons are emitted? So one photon is emitted. Where is the electron is present? Electron is present at excited state. Clear this concept? Now, this process is called spontaneous. In our ordinary light, tube light or any light you take out, the spontaneous emission will occur. So okay. So now I'll go for the third process. Third one, same energy levels I have taken. That is called stimulated. Okay. This stimulated emission is a very important process where we discussed in the last class. The laser. So heading and we will go for that. So in this heading we have taken S is stimulated. Okay, stimulated. So this stimulated we will discuss here. Okay. Now electron. So I will take out another condition for this here. Excited state means absorption in the process. Absorption, electron is present at excited state. Similarly, I will go for here and go for the electron is present at excited. Second condition I will check out. Okay. Now this is your E2 energy level. This is your E1 energy level. E2 and E1 energy levels. Now after 10 to the power of minus 8 seconds also it will not come to ground state. Okay. Then we have to give some extra photon we have to give to excited state. Now we are giving here extra photon. Now already it is received. It is not ready to take out this photon. Okay, it will just touch this electron. It will come to ground state. Okay, this process is called stimulate. Where it is going to touch, it is called stimulate. Now when this electron will come to ground state, it is emitting photon. It is emitting photon. Okay, what is the energy of the photon? E equals to nu. E equals to nu. Now, when electron will come to excited to ground state, is emitting photon. What about this input photon? It not received. It is already excited. It is already taken in the absorption process. Already taken the photon. Then what about that? This photon will come this side. Means there are two photons are coming outside. One is due to the electron will come to ground state and emptying the photon. Another one, what you are giving the input photon. So both photons are in phase, coherence. Because of that, we are getting the high power you are getting due to this stimulated emission. But the stimulated emission is very important for your laser. That's why in heading you have stimulated emission, not spontaneous emission. In spontaneous emission, how many photons are emitting? Only single photon is emitting. It is in the form of waste. But stimulated emission, two photons are combined. We have. So that is useful for the laser operation. So can I take out here? So there is a one question I will take out from this diagrams. What is that? The difference between spontaneous and stimulated emission. Very easy to take out. So what is the difference here, sir? Now here in spontaneous, electron is present excited state, here also excited state. Okay. So when we take out the input photon, okay, here we don't have any input photon. Here we have the input photon. That is the difference between spontaneous and stimulated emission. Single difference you will get. Output will see that output it is emitting only single photon. But here two photons are emitting. Output will consider. Now, so then I will consider here in phase. In phase, there is no second wave we have, second energy we have. There is no word of in phase. Then I consider coherence. There is no word of coherence. This is a major difference between spontaneous and stimulated emission. Very easy to write. No need to by hand. No need to study that. By seeing these two diagrams and carefully draw and take out the difference between spontaneous and stimulated emission. Now I will come to here Einstein quotients. I haven't completed this Einstein quotient. What are the Einstein quotients? I'll use these three figures. I am trying to explain this Einstein quotient and we are going to derive that. Okay, now I'll go for the here from this figure, absorption figure. The rate of absorption are 1 to 2. Okay, so first energy level 2, second energy level electron will going to jump. Now can I take out R12 is directly proportional. We depend on what factors? Number of electrons at energy level E1 means first energy level, that is can I consider N1, okay, and depend upon the incident photons. Can I take out density of photons? Okay, density of photons can I take out? That word I have taken, rho I have taken. So it is depend upon R12 rate of absorption from 1 to 2. So R12 it is depend on the number of electrons at ground state and photons, incident photons. Okay, now I will take out proportional. Now R12 is equals to R12 is equals to, now I will write it here. Can I write here? So I will write here top also. I will write. Now you are getting here the answer. R12 is equals to. So can I take out some constant? I have to take out A, B, C, D. What you are going to take out? I will take out V12. Notation of your note, your book, textbook. Then I will write it here N1 into rho. Okay. So proportionality I will take out. The proportionality I am going to take out. Then you will get here some constant B12. Okay. Why? Because here 1 to 2 the electron will going to jump. That I have taken. That is the equation number 1 I consider. Okay. For absorption we got equation number 1. Can I go for the spontaneous emission? This is spontaneous emission you have. For that rate of emission I will going to take out for this one. Rate of emission R21. Why sir? 2 to 1 electron will come to 2 to second energy level to first energy level. That's why I have taken. It is depend on what factors? It depend on number of electrons at exact state. Can I take out here n is indicating number. So number of electrons at exact state means here E2 second level, that is called 2 I have taken. So there is no incident photons. There is no incident photon. That's why I am not writing here rho. So then I write here R21 is equals to, so some constant I have written. So that constant I have taken A21, that is N2. That is the book notation I have taken. That is equation number 2 you will get. Can I take out equation number 3? I'll go for here equation number 3. I'll take out here equation number 3. So I've read from this stimulated emission. Stimulated emission I will not write it here. So rate of emission once again. This is also emission. Okay, rate of emission 221 only. Rate of emission 221 is directly proportional to, and back factor will going to depend. So number of electrons at excited state means E2, and number of incident photons. Here we have incident photon. We don't have here incident photon. That's why we have written here any row. So here it depend upon incident photons. That's why you have write here in row. We are going to write it here. Clear? Now I will write here equation 3. I am going to erase this thing. Okay, then you are going to get here clearly. So then I write it here, rate of R21 is equals to some constant, that is I have taken B21. So here I am writing here, okay, I have written wrongly, I have written N2 I have to write here, correct or not? N2 I have written here, N2 into rho. Okay, so here I have to write N2. So N2 into rho is your equation number 3. Now we got here equation number 1, equation number 2, equation number 3. Equation number 1 depend on here means rate of absorption depend on number of electrons at ground state means E1 and incident photons, and your equation number 2 R21 rate of absorption, rate of emission depend upon your only on number of electrons at E2, and your equation number 3 rate of emission only depend upon both N2 and number of electrons at excited state as well as input photons also. Okay, now at equilibrium positions, now I'll erase this part. I'm going to write the equation for the Einstein coefficients. Now for equilibrium position, can I go for the equilibrium position? So rate of absorption equals to rate of emission at equilibrium. Okay, at equilibrium. Now at equilibrium, rate of absorption equals to rate of emission. Now rate of absorption, you have only one equation number 1. So rate of emission, both you have equation number 2 and equation number 3 we have. Equation number 2 as well as equation number 3 we have. Can I equate both the equations? Right side factors I am going to equate. Then I am going to equate right side factors. B12 N1 into rho is equals to, so A21 into N2 plus N B21 N2 into rho. Okay, right side of this equation number 1, equation number 2, equation number 3 I have equated. Then what you have the common? What you are going to observe the common? First you are going to observe the common. Here is rho we are getting here. Now this total rho factor I will take out to the left side. Then we will get here B12 N1 rho minus B21 N2 rho. Okay, right side what you have? So A21 into N2. Correct? Can I take out rho is a common here? Rho I will take out common. Then B12 N1 minus B21 N2. Okay. Now here we have A21 into N2 you have. Okay. Can I use right side? Both. Right side I am going to use. I am going to continue this derivation. Okay, clear? Now rho I will keep it here, and I write here the remaining factor. So A21 N2 by this total factor I am writing. The total factor I am writing. What you have B12. Here we have N1. B12 N1 minus B21 N2. B21 N2 I am writing. Okay. Now what you have to take out common? You have reduced this equation. Then Can I go take out here N2 is a common? Why? Because here N2 we have. So okay. So then I will take out here A21 N2 from this here denominator. I will take out the common N2. N2 you will take out B12 N1 by N2. Why? Because we don't have here N2 factor. N2 term we don't have. That's why I am writing here B21 you will get. Okay. So can I cancel out B N2 can I cancel out? Then remaining factors we are writing here. So rho equals to A21 by B12. Okay. So I write here at top. Now I am going to correct here. Okay. Can I write this? Already I think you have taken this definitions. Okay. So all the equation number 1, 2, 3 you have taken. I'll erase and I'll write here. Okay. Now I'll write here. Now, so what do you have to write here? So remaining factor I am writing here. Rho equals to A21 by B12 into N1 by N2. Okay. N1 by N2 minus B21. Okay, right here. So what are B12, B21, A21? These are constants. Okay, it's a constant. Now, can I take out here? You have A21. So, can I take out here in denominator B21 is a common? Okay, B21. Okay, so here I will consider here B12 equals to, right? B21 equals to B21. Means where you have B12 I will consider B21, B21 also B21 I will consider. Okay, now, so in place of this, here I am going to consider B21. Now next, you have B21, similar I will keep it. Now B21 I will take out common. I will take out common. Now what you are getting here? 1 by. So remaining you have, this is also converted like a B21. Now remaining you have N1 by N2 minus 1 you will get here. Okay. Okay, this is end of the equation mathematically. But what happened here? So we don't know what is N1 N2. What is N1 N2? So N1 is the number of electrons at ground state. N2 is the number of electrons at excited state. Then how you are going to take out this equation? How you are going to calculate number of electrons? So maximum Boltzmann is given this equation N1 by N2. We are going to use here Boltzmann equations. Okay, in statistical mechanics, Boltzmann is given equation. Okay, so he is given that N1 by N2 equals to e power E2 minus E1 by kBT. A suffix B into T. What is here? Kb is a Boltzmann constant. T is absolute temperature. E2 you know that energy level, second energy level, and first energy level. We know that difference between E2 minus E1. E2 minus E1 we discussed here. E2 minus E1. Suppose we will consider here in spontaneous. We will consider this is your E2. This is your E1. Okay, when electron will going to jump from here to here, then it is emitting photon. What is the energy of this photon? E equals to h nu. Can I write here this equation? E2 minus E1. E2 minus E1 is h nu. E2 minus E1 is h nu. Means, can I write it here in place of E2 minus E1 h nu? Then this equation I write here like this. This equation. So N1 by N2 equals to e power h nu by kBT. E by E2 by E1 equals to h nu by kBT you will get. Now, so I will substitute here this value here. Can I put here this equation? Slowly I am going to complete. Here up to we have the mathematics we have. There is no use here physics. The first started with physics concept, then I am going to use some mathematics. I will bring here, then we get final equation is this one. But we don't know what is N1 by N2. Then once again I will go for the physics and we are going to use for the Boltzmann equation in statistical mechanics. Then we will get here N1 by N2 value. Can I put here this value here? The rho equals to, so what is the value here? A21 by B21 into 1 by, so I'll keep it here. N1 by N2 value is e power h nu by kBT minus 1. Okay, clear? So this is the final equation what you got. Now what do you want, sir? Einstein coefficient means A21, B21 we have. So we will compare. We don't know what is the A21, B21. Now we are getting with something factor into A21, B21. Now once again we will compare with your Planck's radiation law. Planck's radiation law. Now the Planck's radiation law, I will compare with this thing. I will write it here. I will erase and I will write it here. Then Planck's radiation law, we will compare it. Can I take out here? I haven't taken equation number 3, equation number 4. Can I take out equation number 4? Equation number 4, right? Now that equation number 4 compare with another equation, the Planck's radiation law. I write it here. Rho equals to once again. Okay. Now here A pi h nu cube by c cube. The Planck's is given this equation. Now into 1 by e power h nu by k b t minus 1. See similar. So this is equation number 5. So compare this equation number 4 and 5. Compare equation number 4 and 5. 4 and 5 in here. Compare this. The right side factor here. Both are same. Both are same. In place of A21 by B21. What do you have the value? A21 by B21. Okay. A21 by B21. What do you have value? 8. Can I take out here? 8 pi h nu cube by c cube. Okay. So this A21 by B21 is known as Einstein coefficients. A21 by B21 is known as Einstein coefficient. This is a very simple derivation you have by using these 3 diagrams: absorption, spontaneous, stimulated emission. Okay. Definitely we are going to ask this question in for the long question, 7 marks question. Just you practice once or twice, you will get this equation.